Okay, so as you can see, I'm gone today. I have to go to another school to see some of the stuff they do with their technology, so we can steal it and use it at Mount Zion next year. And it was kind of short notice, so I didn't really have much planned for today. So I thought, here's what I'll do. Um, I've got a few things I want to cover from section 7.7 because I know that was a tough, weird section, and we also had the 4-day weekend. So even if you knew what you're doing Thursday, coming into yesterday, or even this morning when you tried to do your homework, some of you were probably a little confused. So we're going to run through a few problems of that. And then luckily 7.8 is a pretty simple section as far as what we do with it. We could get really out of hand with it and make a bunch of graphs, but we keep it very, very simple. So your assignment then, you have a few things you have to do. You have to, with the notes that were given to you, fill in the problems, okay, and answer, that I go through here in class. If you need to, I'm going to go as slow as I can. So if you need to, within reason, pause it, okay? Take a second if you need to, if you got a question on something, but you have to copy everything down. And then at the end of the hour, the sub will collect that, and that'll be part of your homework for today. Then after we get done with after I get done with this video, you're going to have, I think, 5 or 6 problems. I can't remember off the top of my head how many I put on the worksheet. But you have problems in the worksheet that will cover stuff like this from 7.7, and then the new stuff from 7.8. That's also due by the end of the hour. Now, for all this, you get to use a calculator. So I want to see the work and the setup to these problems. I don't need to see, all the handwork of multiplying. You're going to get to use that. But you've got to write down the setup form. You cannot just write down answers. And then tomorrow, what I'll do is the homework that was due today, that 7.7 worksheet, that will be due tomorrow. So if you made any kind of weird mistakes to it, if there's anything you didn't quite understand, hopefully the video here kind of clears that up and you get a chance to sort that out and then make that homework a little bit better off. And then Tuesday we will review, Wednesday we will review, Thursday will be your test over chapter 7. Okay, so that's how the week's going to work out as well. Okay, so enough just blathering and preamble. Now let's get started and jump into stuff because I've only got so much time before some of you guys are going to get confused or get bored and stop paying attention if you haven't already. So the first thing is, number 1 here, simple interest. The simple interest formula, which we talked about in class, was interest equals principal times rate times time, where rate is a percent as a decimal, principal is your initial amount, time is in years. Okay. So for number 1, here, this 1,000, that's the principal. This is the rate, but I'm going to have to turn that into a percent, and here's the time. And luckily this is in years, because if it's not in years, then I have to divide it by 12. But again, this has to be a decimal. This has to be in years. Okay. So interest is principal times rate. Now 2.5% is 0.025 as a decimal. Okay. So it's 0.025 and then times 3. So that's the work I expect to see. 1,000 times 0.25 times 3. And then all you have to do is go get your calculator out. Mine will open up. I don't know what's going on here. Wabbit. Sorry about that. I had to pause it real quick because my calculator didn't want to pop up. So we've got 1,000 times make this nice and big there so you can see. 1,000 times 0.025 times 3. And we get 75. Okay, so interest on this is $75. Now number 2 is the exact same problem, but this time we have at a principal amount of $575. Our interest rate is going to be 0.15 as a decimal, and then our time is going to be 10 years. So interest equals $575 times 0.15 times 10. And then again, get the calculator out. So we'll do then 575 times 0.15 times 10. And that gives us $82. Wow, that gives us $862.50. That's a lot of interest. And again, remember this is money, so we go to the nearest cent. So it's not just 862.5, 862.50 in dollars. Now the next type of example is compound interest. And this was the part that I think if you're going to have struggled with the homework from Thursday, it's going to be this. Okay. One, they make the numbers a little more complicated. For some reason, they like to do weird decimal percents. And then there's a little quick process to this that's a little different. So here's how this works. When we go back to that previous problem, what I did here on the calculator, all that's happening is you're taking that interest and you're just multiplying it 10 times because it's 10 years. So you're finding 15% of $575, multiplying it by 10. Or you're finding 2.5% of $1,000 and multiplying it by 3. That's not how real interest works for loans, unfortunately. What happens is when you have this guy here, again, this is your principal, this is your rate, this is your time. We still kind of, the idea-wise is start off the same. Find 4.33% of 2853. So 2853 times 0.0433. But we don't multiply it by a 5. Okay. So 2853 times 0.0433. That's $123 roughly and 53 cents. And then what happens is this, is that we add this back on to the original amount. Well, that's where Mr. Moyer gets lazy at and says, I don't want to add this back on, because if I add it back on, I got to go 2,835 or 53, 2,853 plus $123.53. That's kind of a waste. This guy right here is 100%. Okay, that's what he is. The 2853 plus the 123.53. This is 100% because it's the whole amount. This is 4.33%. So what I'm really doing is finding 104.33%, which is what that 2976.53 is. Okay. So instead of me going to the trouble of finding this, finding that amount, adding it back on to this, what I like to do lazily is go, oh, let's find 104% of, well, 104.33, which 104.33% is 1.0433. So find that instead. And if I do that real quick, 2853 times 1.0433, I get $2,976.53, just like I got up here previously, $2,976.53. And then the 49 left over we ignore because it's not, this is money, I have to round up or round down. So it's a lot easier to do this way. Now here's the annoying part about compound interest. When you go back to the simple interest problems, okay, when I go back to these problems, what I was really doing, okay, is I was finding interest one time. Though if I go back to this, like for instance this one here, okay, if I do 10 or 2.5% of 1,000, which is 0.025, okay, I get $25. And then that happened 3 times. That's why it was $75. Well, here's the thing. With simple interest, you just find the interest on the original amount. Compound interest, this problem, you have to actually now define the next year's interest because this is just year 1 here. To find the next year's interest, what you have to do now is take this amount for year 2 and then find 4.33% of it, and then add it back on, which, okay, well, to make that easy, what we'll just do is we'll take this amount here and multiply it by this instead of finding 4.3% and then adding it back on to this original amount. We just say, no, take this amount, multiply it by this, that'll give you year 2. Then you get a whole new amount, and you take this, find 4.33% of it, add it back on. You keep doing it over and over again. You do it 5 times because there are 5 years. So what Mr. Moyer does, because he's lazy, he doesn't like to do that over and over again, is he cheats a bit. I say, hey, you know what? Let's take that original amount of $2,853. And then I multiply it by 1.0433 5 times. One for each year that this is under interest. So year 1, year 2, year 3, year 4, year 5. So instead of me, I'll move this up so you can see now. So instead of me, again, doing all this business here, finding 4%, adding it back on, and then starting with this number here, and going, okay, that's year 1. Let me find 4% again, add it on to this. Okay, that's year 2. Find 4%, add it on again, year 3, 4, and then 5. What I can just simply do is multiply this guy by this 5 times. And some of you mentioned in class on Thursday, hey, can I just use an exponent for that? And you're right, you can, but not all calculators have that built in, and the ones you borrow from me don't. So that's why I just do it this way. Yeah, put it right there. I think that should be visible enough for everybody. So I do 2,853 times 1.0433 times 1.0433 for year 2 times, that's the 3rd year, that's the 4th year, and then here's the last one. And then I get $3,526. And then I got to go to 2 decimal places, so it looks like 53, so 53, because it doesn't round up, 0.53. So we get then $5,326.53. But again, all I'm doing is finding 4% of each amount over and over again and adding it back on. Well, this just takes care of that in one simple step for me, so I'm not doing it like 10 times just to basically kill time. I can do it in one step then. Okay. So the next problem then, number 4, we have $821. Okay, so there's our principal. 6.5%, well, that's 0.065%. There's 0.065 as a decimal, and then here's our years. And again, this is compound, so that's how many times I'm going to do this. So what I've got is I've got 100% plus the 6.5%, which is 106.5%, which is, oh, you're running out of space there. Let's put you down here for now. Actually, let's put you in the background, which is 1.065 as a decimal. So there's my rate. So I'm going to take then for my interest, actually it's the total everything, but we'll just call it I. It's going to be the principal, $821, but times 1.065 3 times, because it's 3 years. So year 1, year 2, and year 3. Okay. So now we get our calculators out. I don't really have, right here I think will work. So 821 times 1.065 times 1.065 times 1.065. And that gives me $991 and 73 cents because it's 0.7266. That's 72 is going to round to 73. So $991.73. There we go. Okay. So that's kind of like in 15 minutes here, a review of section 7.7. Okay. All right. So let's clear this out. All right. So now let's take a look at section 7.8. 7.8 is circle graphs. Okay. There's two parts to this. We're just going to do one because if I were there, we'd do the other part, but it isn't on your chapter test and it isn't on the semester exam. So this year I just kind of have to skip it, unfortunately, being gone. But we do two things. We could create circle graphs, which again, like I said, we're going to skip that. Or what we're going to do is use circle graphs to answer questions about number of people involved in something or whatever. So let's see. We've already talked about percent problems. I've already done that. Circle graph basically is just what we called back in grade school a pie chart, okay, or where you've got a whole circle representing a bunch of groups so you can compare things, and then each portion represents a percentage of an amount. So, so for this one here, 38% is the biggest group, not only physically but percentage-wise. So oil carriers are the biggest group, and then we know 4% of whatever we have is container ships, 16% is cargo ships, ore and bulk carriers is 30%, passengers and ferries is 0.5%, and then all others are 11.5%. The strength of a circle graph is that it gives you a quick visual representation comparing like proportions. Okay, look, this is not quite half, but it's definitely more than others, that kind of stuff. It doesn't always give you, most times it actually doesn't even give you that, the total number of people possibly that are being represented or objects. In this case, these are actually boats or ships. So it doesn't give you that. So you'd have to know the original amount surveyed to know that, and that's basically what the homework problem is, or the section problems or the application is. We're going to give you a circle chart. We are going to give you the total number of people. You figure out how much is in each group or some section to compare the two. So here we go. So here's the first example. It's not in your notes, but just to walk through real quick. So we have a circle graph, top issues facing the U.S. A bunch of students were interviewed with this. So 50,000 students were surveyed. How many more students feel the environment is more of a concern than education? Well, 29% feel the environment is a concern. 11% feel education is a concern. So what we'll do is we'll figure out how many people of that 50,000 thought the environment was a concern. So you find 29% of 50,000. Now, in this, you can do the proportion or the equation to find your amount, but you're given the percent, you're given the whole, so you're trying to find the part. They use the percent equation because it's just decimal percent times whole to give you part, and that's what I'll use for the video. But you could do proportion or equation, either one works fine. So they found 29% of the students, which was 14,500. Then they found 11%, which was 5,500. And then if they want to know how many more prefer or concerned about the environment over education, they just do 14,500 minus 5,500, and that gives you about 9,000 students we feel are more concerned with the environment than education. So here's the first example you have on your sheet. Coffee. The circle graph at the right shows the results of a survey about favorite kinds of coffee. If 500 people were surveyed, how many more people like mochas than lattes? Okay, so here we go. So look at this problem. Okay, this is, again, you have the exact same one on yours. Okay. We know we're trying to figure out how many more like mochas than lattes. Well, we know 60% prefer mocha and 8% prefer a latte. Okay. So we know obviously mocha is more than latte, but the question is how many more? Well, what that means is we've got to find 60% of 500 and 8% of 500. Okay. So for mocha, again, percent equation is part equals percent as a decimal times whole. Okay. So the mocha part, well, 60% as a decimal is 0.60, and the whole amount were the 500 people. So 0.6 times 500. Dang it, wake up my calculator. 0.60 times 500. That's 300 people. So 300 people preferred mocha. And then latte, well, that part is 8% of the whole. So 0.08 times 500, which I think will be 40 off the top of my head, but I want to double check that. So 0.08 times 500, yeah, 40. Okay. So we know 300 liked mocha, 40 liked latte. So how many more liked mochas than latte? Well, 300 minus 40 gives us 260. So 260 people liked mochas more than lattes. Okay, give you a chance to catch up before we jump to 2. Okay, number 2. The circle graph at the right shows the results of a survey about favorite kinds of television shows and movies kids prefer. If 5,564 kids were surveyed, so right there before I know anything, that's the whole amount. Okay, so if 5,564 kids were surveyed, how many more preferred cartoons to horror? Okay, well, we're looking at cartoons. Say cartoons in blue, horror in red. So here's horror, 6%. Here's cartoons, 20%. Okay. So cartoons is 20%. So we're going to have to find 20% of 54 or 5,564. So 20% is 0.20 times 5,564. Okay. And then horror is 6%. So 0.06 times 5,564. So we'll find those amounts out real quick. So 20% is 1,112.8. So I'm just going to say 1,113 kids. We're not going to say there's a fraction of a kid. We'll just flat out use the full kid. And then it's 8% or 6% of 5,000. So 0.06, 5,564. Whoops, I forgot to do the times 5,000. That gives us 333.8. So that'll give us 334 as well for that. So now we know that we have 1,113 kids that like cartoons. We have 334 that like horror. So we'll do 1,113 minus 334. And that gives us 779. So 779 more students prefer cartoons over horror films. There we go. Okay. Okay, and then if you haven't caught up again, you can always pause it. Okay, then. Now, number 3, last one. Entertainment. The circle graph at the right shows the results of a survey about what students feel will be the biggest environmental challenge of the 21st century. Wow, they're big on environment in these problems. If 834 students were surveyed, how many fewer students think that the concern... Okay, so again, before I do anything, again, that's the whole. 834 kids. Okay. How many fewer students think the concern for where to put the garbage will be not as challenging as where to store the nuclear waste? Okay, so where to put the garbage is one group. Where is this? Where to put the garbage? Where to put garbage? Okay, 5%. Okay. Is where to store chemicals and nuclear waste. Where to store chemicals and nuclear waste. Okay, so we can see here, again, hopefully this is big enough and visible enough for you, but if not, you got your sheet in front of you. 15% are worried about storing, 5% are worried about where to put it at. So we know more here than here. Okay. So let's find 15% of 834. So 0.15 times 834 which is 125. We'll just say 125. It's 0.1, but we'll just say, oops, not 125. Now we're at about 5% about where to put the garbage at. So we're doing 5% of 834, which is 0.05 times 834. So then again, we get out our calculators. And that gives us 41.7, which we're going to say is 42. Okay. All right. So again, we found 15% of 834 to figure out who was worried about storing chemical waste. 5% is worried about where to put garbage at, which is about 42 people. So how many more are concerned about storing a waste than putting away? Well, we'll do 125 minus 42, which gives us 83. So in our survey, 83 kids were more concerned about where to store nuclear and chemical waste than where to put garbage. Okay, so again, hopefully this only took about a half an hour or so. You should have about 15 minutes then to work on your 5 or 6 problems, which really will take you probably 5 to 10 minutes, if even that. So yeah, so there you go. Again, both of those are due at the end of the hour. And like I said, tomorrow I'll collect the worksheet I gave you on Thursday because I'm going to want to talk about that when we have everyone together again and I'm in the classroom. So thank you.